Good morning, developers. If you are new to the channel, my name is Rob, and in this video, in 1 hour, I'm going to give you everything you need to make your own WebRTC application. And the structure is going to go like this. First of all, we're going to talk about what WebRTC is. You may already know what some things are. You may be confused or don't know what some are. If you're like me, I started learning back in 2015, and back in those days, I thought I knew what stuff was, but I was confused. I just didn't know it. So this will allow us to make sure that we are on the same page about what it is and what it's capable of. The second thing we'll do is I am going to draw out the entire process from beginning to end visually in as simple a terms as I possibly can. So we'll have a browser over here, could be a PlayStation 5, it could be a Windows desktop, we'll have one over here, it could be a Samsung phone, it could be a MacBook Pro, right? They're somewhere on the internet, they're not connected. How do we get them connected? And this may be the most valuable thing in this entire video for you because, at least for me, it's what I needed so bad back in those early days is for someone to break it down in a simple term. What typically happened was there wasn't near as much information available then, but I would go to the docs or a tutorial and I would start reading and I would run into ICE candidate. Oh, okay, I don't know what that is. So I'd click on it and it would take me to another page. And I would start reading there, and they'd talk about stun servers and turn servers, and I'm clicking on more links, and 3 hours later, I have literally 50 tabs open, and I have no idea what anything does, and so I go hide in the closet until I'm brave enough to try again. So we want to avoid that, right? That's not necessary because it is going to be a lot of new material, but it's not that complicated. It's just going to be different because you're used to HTTP. You're probably a web person and you're used to doing things on the web. This works a little bit differently, so we'll talk through those concepts. And then third, I have already made a project and I will help you pull it down. I will help you get it running, and then we'll talk through it line by line. We are not going to code together, okay? And if that doesn't sound interesting to you, please let me explain. Typically, when I teach something new, I would like to start with an empty folder, and you type every single line along with me. Everybody has been there, at least it seems to happen to me a lot, where I want to learn a new thing, and the teacher says, hey, go download this repository, run npm install, pip install, Gradle, whatever, and then we make a new file and we start coding. And I'm thinking, hey, you can't do that to me. I don't know what happened in all those files we downloaded. There's 15 here, and do I always have to use these? Are there security concerns? Are there dependencies in there that I don't know about? Did you make architectural decisions? What's going on here? We never talk about them. Okay, that's not what we're gonna do, right? That really frustrates me because I want to be able to apply this, and I want you to be able to apply it as well. I'm gonna have you pull the code down and we'll talk through it line at a time, but we're gonna do that last because I want to go through conceptually how it all works first. And there are two reasons why I'm not going to code with you. The first reason, it is a really big distraction when we're working on something that's got all these new concepts. You're going to be working hard to try and figure out what all the pieces are, right? What's the signaling server's job? Why do we need it? What is the peer connection? What are its methods again? Adding in coding, and really what you're going to be doing is typing because you're going to be trying to keep up with me. If you are typing, you're gonna make typos. Your code's not gonna work. You're gonna pause me, and you're gonna be trying to compare our screens, and that's just another layer of complexity that we can get rid of. As I've had a lot of success with this in these types of situations. The second reason is when you are ready to code line by line, but the second reason is because it takes a really long time to make a WebRTC app line at a time for someone who's brand new. Okay, if you are ready or when you are ready to do that, I have two options for you. One, I am making a playlist on YouTube. Okay, it's not finished as of the making of this video. It might be when you're watching this, and if it is, I'll link it and you can go through that whenever you are ready. There you go. If it's not ready and you are ready to keep going and you want to learn from me, I also have a Udemy course. Now it costs money. I'll put a link in with a coupon. It'll be $10 to $13, something like that. And that is ready to go right now. So that may be the only option you have. If you want to wait for the playlist, that will come out. I'm just not 100% sure on when it will. Okay, so that's the structure. We're going to do what is WebRTC. We'll talk through how does a connection happen? How do we get the video feed to go? And then 3, we'll walk through the code one line at a time. Okay, so what is WebRTC? We'll look at the docs here in just a second, but real quick, it is a way to do a video chat in the browser. It allows us to pull down the feeds and then send them directly to another browser, and it is awesome. It still blows my mind that literally in one line we can pull all this data back. It takes a lot more to send it, but we will get to that. Okay, let's look at the docs quick. WebRTC, this is Mozilla, so these are the MDN docs, but WebRTC stands for Web Real-Time Communication, is a technology that enables web applications and sites. Okay, we'll stop there. Web, right? It's in the title, WebRTC, and they are for web applications. This is a browser thing. WebRTC exists entirely in the browser. Now, we are going to need a server, and I will get to that, but that's not strictly speaking part of WebRTC. WebRTC is a JavaScript API. So if you have a browser, right, a Windows desktop, a Linux desktop, an iPhone, a PlayStation 5, maybe you've got a coffee maker with a browser in it, right? Whatever you've got, it is a browser thing that runs in JavaScript, and it's part of the language. Okay, we don't have to install anything. It comes, but it's not Node. It's not C++. There's no servers involved, strictly speaking, in the WebRTC part, though again, we are going to need one, but WebRTC is a browser thing, okay? It allows you to capture and optionally stream audio and or video, and then you can also exchange arbitrary data without an intermediary, okay? So we'll stop there for just a second. I am going to divide WebRTC up into two pieces. There is that first part they meant, capture. Okay, and that is GetUserMedia. I will refer to it at times as GUM, but GetUserMedia is how we can pull down the camera feed, we can pull down the mic feed, and we can even pull the screen down. Okay, this is incredible. Again, it's one line literally to put this inside of a variable. Doing stuff with it is a little more complicated, but GetUserMedia allows us to get that stuff. We have to ask for permission. It would be really bad if we didn't, because that would not be safe. But once the user grants permission, we have this stuff. And then the second part there was optionally stream audio and or video media without an intermediary. So the other part, I'm going to put PC here, that is short for peer connection. There's literally a JavaScript object called RTC peer connection. We are going to make one, we'll call it peer connection, and this is peer-to-peer. Okay, what does that mean? Well, in the old days, this is how it worked. Because video chat has been around for decades. I mean, it wasn't very good, but you could add a Skype plugin in the browser or something like that. We don't have to do things that way anymore, because this is how it used to work. You have client 1 and they want to have a video chat with client 2, right? Browsers. In order to do that, we had to have a server, and its purpose was no more than you send me your audio video feed, and I will send it right on through to the other client. You send me yours, and I'll send it right on through to the other client, right? That's how it worked, is we had to pass it through the server, but this is obviously silly, because the server's only acting as a pass-through. So this creates a whole bunch of complications. It increases bandwidth, right? Or it increases latency. It takes time to send it here and then time to send it here instead of just going straight there. There's potential bugs that happen on the server. If the server goes down, the connection would be severed even though the browsers are still okay. There might be security problems, right? There's a whole myriad of things. What WebRTC allows us to do is get rid of that. We will create the peer connection, that's the dot here, and then we will connect directly to one another and pass the stream back and forth. This is as fast as you can possibly be because the computers are connected directly to one another. Okay, exciting stuff. That's the peer connection part. The GUM, or the GetUserMedia, is getting the feed, and then this is passing it back and forth. Okay, a couple things to note here quick. This connection is UDP, and I want to talk about that briefly. WebRTC uses UDP, and that stands in contrast with TCP, which you probably are more used to working with. If we look at the docs again quick, it says at the bottom there, it says we can exchange arbitrary data between browsers. Okay, does that mean that you would use this and you could pass files back and forth instead of using WebSockets or Socket.io? Okay, the answer to that is no, because it is UDP based. What is the difference between UDP and TCP? Well, HTTP, again, that's probably what you're familiar with as a web person. HTTP is built on top of TCP, and TCP is reliable. It has acknowledgments built in. It is stable, so if there's latency, it will introduce latency if the network is overwhelmed, etc. Okay, TCP is good because it can guarantee a lot of things. And you think, well, Rob, these are all good. Why would we always use that? Well, because UDP is fast in all capital letters. It doesn't care about those things. It sacrifices nothing for speed. Okay, why would you want that? Well, think about it. If you're on a Zoom call or a video conferencing or whatever, and suddenly everybody freezes because your internet's gone down and it's down for 10 seconds, when it comes back up, do you want to pick up where you left off and people start talking again, just like you unpaused it? No, you want to pick up exactly where things are at right now. And you maybe have to say, hey, sorry, my internet went down. I missed the last 10 seconds, but you'll be live. Same thing with an online video game. That can't be TCP because if you're in a fight, when your hero's in a fight and your connection stops, the rest of the world doesn't wait for you to catch up. Your hero might die or your city gets taken over, but then your internet connection catches up and you need to know exactly where things are at so you can start playing again. We use UDP on these connections. WebSockets, and then we're going to use Socket.io, uses TCP, so they are very much complementary. They do not compete with one another. You never usually have to make a hard decision about whether to use UDP or TCP. This is fast and unreliable. This is reliable. It's still fast, it's just not as fast as UDP. Okay? So that is a brief overview of what WebRTC is. We have two browsers that we can pull down their camera, their mic, or their screen. We can connect directly to another browser and pass it back and forth. So we don't have to send the video feed up to the server, right? More latency, maybe security. Maybe you don't want the server to have your video, and it makes it as fast as possible. Okay, let me clear this out and let's talk through how the process works. So we've got our two browsers somewhere on the internet, client 1, client 2. We don't know what device they're on. We don't care. They're at our website, which means they're running a browser, and they want to have a teleconference or a video chat. And we are going to use WebRTC. What's the process for that to happen? What are the components? How does everything work together? And again, this is what I wish someone would have showed me about 10 years ago when I first started working on this stuff. Watch it as many times as you need to because it's conceptual, like this piece does this and so on. It will really help when we go and we code. I have a file called tasklist.md in the GitHub repo. I've got a link down in the description, but I'll put it up here real quick. There are 23 points here. There aren't really 23 points because we do the same thing on both clients. We just do them in kind of different orders. So it's really about half that, but you can refer to that as we talk through things. And I will try and mention some of the numbers. I'm not going to write them up on the board because we're going to get messy as it is. Okay, we're going to approach this by asking the question, if I'm client 1, I need to know what? In order to get to client 2, what WebRTC stuff do I need to have in order to establish this connection? Okay, the first thing is I need to know where you are. Okay, client 1 needs to be able to find client 2. We'll come back to that. The second thing is I need to know what you are sending. Okay, if you think about this, like if you had a Brazilian person who was going to call a Chinese person on the telephone, the Brazilian person is going to talk in Portuguese and the Chinese person is going to talk in Chinese, and that's not going to work. They're not going to be able to understand each other. In fact, they'll frustrate each other. So if client 1 here is going to talk to client 2, and they're going to be on different devices, at least potentially, right? An iPhone and a Linux desktop. They're going to have different codecs. They're going to have different timings. We need to not only be able to find each other, but we also need to communicate, hey, this is what I'm going to send to you so that you can make sense out of it, okay? Those are the two things that we have to solve, and this big long list we're going to have over here is going to solve those two things, okay? So the very first thing that is going to happen is that getUserMedia. Somebody has to start a feed, give the browser permission to pull down the video, audio, or the screen feed. Okay, we are going to block the app until that happens. Technically, you can do some stuff without it, but I'm going to block it until someone gives us access, because we can't do anything with the peer connection if we don't have anything to send. Okay, that's number one on that task list. Number two is to create the peer connection, and I'm putting a line under it. We are going to pass or do a bunch of stuff with the peer connection. This thing is really, really important, and I'm going to draw a dot here on both sides. That is our peer connection. That's the thing, or sort of like the network socket that is going to connect to the other side. This thing has all the cool methods and all of the stuff that we need. It's the capable part. Okay, that's step two. Step three, we are going to pass stun servers to the peer connection. Okay, first scary term, at least it was for me, because I kept running into it and I didn't understand what it meant. Okay, we have an issue here. So coming back to the where are you, could you just give the other person your public IP address? You can't, because of something called NAT. So there's network address translation. There are also firewalls, and there is also VPNs. Okay, these two, you may know what they are, you may not. VPNs mask your IP address, so you're sitting in front of a different IP. Firewalls are for security. It kind of works the same way. NAT, well, back when IPv4 was created in the early 80s, there were 4 billion IP addresses. Okay, that's a ridiculous astronomical number. We'll never need that many. Except we do. We have way more than 4 billion devices connected right now, so we don't have enough IP addresses to go around. So at the very least, coming in here and hitting this, you're not going to be able to get to this with a public IP address. You're going to hit some kind of router, and the router is going to be in charge of, I've got this device over here on it, got this device, yes, I have this device, and so on. So we need to figure out, how do we specifically get to this client? Otherwise, we're going to be sending the feed potentially to the wrong place. Okay, so this creates a problem. And the stun server is how we solve that problem. The stun server stands for Session Traversal for NAT. Okay, so remember this connection, which is not established yet, so I'm not going to draw it all the way across. This is UDP. And what we do is we go out to, we're going to use Google stun servers. There's a bunch online. They're free. Almost all are free to use because they're super cheap. But its job, we're going to have our client, or rather our peer connection, we're going to pass the stun server. It's going to go out and say, hey, Google stun servers, I want to tell somebody how to get to me. Could you please figure that out, right? Trace a route, and then I'll be able to tell them how to get here. Google will do that, and it will send back what are called ICE candidates. Okay, so another scary term. ICE stands for Interactive Connectivity Establishment. It's really, really fancy way of saying, hey, I found a way for you two to connect. If you give somebody this ICE candidate, it will be a route to get to you. Okay, I'll show you when we get to the console, but that is what the stun server does. Now, we're not going to use this for a while because we have no way to get it to them. We can tell them how to get to us, but we don't actually know how to give it to them yet, so we still have a ways to go. But we're going to pass the stun server when we create the peer connection, and it is going to generate some ICE candidates so we can answer this question. Here's how you get to me. So rather than where are you, we are going to get to that, but we're going to answer the question, here's how to get to me. Okay, so those are our first couple. Number 4 is we need to add the tracks. Okay, and adding the tracks, maybe that sounds a little bit confusing, but when we run GetUserMedia, we create media tracks, and these are very common JavaScript things. They've been around for a long time. They're not new with WebRTC, but a media track, it can play inside of a video tag. We need to take those tracks and we need to add them to the peer connection. Okay, you'll see why in just a second, but when we are ready to start sending data over to the other side, that's what we're going to send, are the tracks that we added to that peer connection. Again, this dot, I'll make a note here, that is the peer connection. So we've given it stun servers so that the stun servers can find out how to get to this computer. We've added tracks so that once we've established the connection, the peer connection has something to send. Okay, now we're gonna answer this other question, what are you sending? Well, once we have added the tracks, we are going to, on this side, create an offer. Okay, maybe sounds scary. Let's break it down because it's not too bad. What is an offer? Well, we're going to go a little bit farther here and go to another scary term. WebRTC has an RTC, so real-time communication, session description. I'm not going to write the whole thing out, okay? An RTC session description is an object, and it has two things. It has a type, and it has an SDP. Okay, what does that mean? Well, the type is going to be one of two things. It is a string of offer or answer. So whoever made it and whoever has it will know which side this is. The other thing stands for Session Description Protocol. And the Session Description Protocol has the answer to that question. I am sending this codec so that when you get the video feed, you'll know what codec it's in. It has the timing information. So there's no reason to go into that detail now. But this SDP is going to be on client 1. This is what I'm going to send. I'm going to get it over to you to client 2 so you'll know what to expect. Client 2 is going to do the same thing, except instead of an offer, it's going to be an answer. It's an object. This side, when we create the offer, is going to have a type of offer along with its feed information. We can't create this until we've added the tracks. Technically you can, but it would be useless because the SDP would be pretty much empty. I've done that before. Client 2 is going to do the same thing, going to create the answer, which is going to have a type of answer, and an SDP with its information. We need to get them to each other. So again, the where are you, that's the ICE candidate. We're going to get them to each other, this SDP, and that will answer those two questions, okay? So we create an offer which comes up with this RTC session description, which has the type and the SDP in it, okay? Another, I'm going to call it kind of tricky thing, the peer connection, let's actually put it, let's put it underneath peer connection. There is a local description. It's actually a method called setLocalDescription that belongs to peer-connection, and there is a remote description. Okay? The local description means this is my RTC session description. So when this side creates an offer, it is going to run setLocalDescription, and it's going to hand the peer connection this so that the peer connection knows my type is this and my SDP is this. Once client 2 sends its over, we're going to run setRemoteDescription, and we're going to set its RTC session description, which has its type and its SDP. Okay? Again, I know there's a lot of stuff here, but it's really just answering these two questions. Stun, an ICE candidate. We got to go out, we got to find out a way to get here. Google, could you please tell us? Here's an ICE candidate, that's a way to get to you. Great, got it. We need to add tracks to the peer connection so that we actually have some data. We need to create an offer. An offer is just this thing. The offer has the type and the SDP. The SDP is what I am sending, or the format, so to speak. And we're going to have to hand it to our local. Once we get theirs, we're going to hand that to our remote. Okay? That's how the peer connection works on the client side. I think that takes care of us up through number 7. From number 8 and number 9, we get into sort of the other side of it here, or the side that, as I said, we have to have a server, sort of, okay? How are we going to get these? We need to send this thing over to the other side. We don't have any way to get to them, and we don't have any way to give them our ICE candidate so that they can find us. So what are we going to do? This is where the signaling server comes into play, okay? And this might be confusing, but it is not part of WebRTC. The reason for that is because once you have created this, once you have the type and the codec information, you can get it to the other person any way you want. Technically, if you wanted to, you could print it off in the console, you could copy it, and you could paste it to Twitter. And then anybody out there could paste it into their own app and start a web chat. That's silly, but you could do that. They give the example in the docs of carrier pigeons. Back in the Middle Ages, you would tie a note to a bird's ankle or foot, and it would fly home, and that's how you could send messages back, maybe if you were at war. You could do that. You could train pigeons, and you could literally write down the object on a piece of paper. It flies to this person, and they take it off the bird's ankle and write it down, and then put it in the console, and then you could have your chat. Now, I hope no one has ever done that, but you could. They haven't established a way that you're supposed to do it. But realistically, the way that everybody does it is with a WebSocket server. Okay, so we are going to create a Socket.io server. If you're not familiar with Socket.io, it is a library that uses WebSockets almost all the time under the hood. I have a video on why you choose Socket.io over WebSockets. I have other videos on how Socket.io works and so on if that's interesting to you. But this thing uses TCP. So our connection between the browsers is UDP, really fast. Want it to be live. Socket.io and WebSockets use TCP because we need this to be reliable. We want to send some information up to the Socket server and then over to client 2, and we need to make sure that it gets there. Okay? What do we need to send? We need to send those two things. What are those two things? Where are you? It will be the ICE candidates. What are you sending? It will be this thing, the offer. The offer, which has the type and the codec information. Okay? Why do we need this thing? Why do we need, and I'm going to put on here, the signaling server. Why do we need this? Why can't we send this? Because this is going to be a domain. This is our website. Everybody on planet Earth can get to this thing. It's going to be oursignalingserver.com, right? Or whatever your signal or your node server is going to be. So we are going to send to the signaling server, number 8 and 9, we're going to send the offer. Again, the offer is this thing. It has the type, which is going to be the offer for client 1, and the SDP, which is this client's codec information. And as they come in, we are going to send up our ICE candidates. This is the what I'm sending, and this is the how to get to me. The signaling server is just going to wait. Okay, I've got your stuff. Great. Once somebody else comes in and wants to talk to you, I will send this on to them. We do not send the feed. We only send the offer and the ICE candidate up. Okay, that is 8 and 9 in that task list. Now the next part is going to be over here for client 2. Client 2 is going to load up pretty much all the same stuff. And I think number 10 is joining the socket server. That just means that we're going to take from client 1 over to client 2. I'll put here the offer and the ICE candidates. So these were sent up from client 1 to the signaling server. They're going to get sent over to client 2 because both clients can find the signal. Okay? So client 2 now has the remote. Client 2's remote is client 1. Client 1's remote is client 2, right? The other side is always going to be the remote. That means client 2 has an offer. So what does it need to do? It needs to run GetUserMedia. Needs to create its own feed, its own audio and video and so on. It needs to create its own peer connection. What does it need to add to the peer connection? Well, it's going to have to send stun servers. Why? Because we got to find a way to get to it. Because over here, we have all these same problems. We've got the NAT, we've got the VPN, and we've got the firewall to consider. So this is going to need to get its own ICE candidates. It's going to need to add its own tracks from GUM to the peer connection so that once it's able to send stuff over, it will have the right media. Once it has added tracks, it is going to, I'll put underneath here, it is going to create an answer. And an answer is the same thing as an offer, but the type is going to be answer instead of offer. Okay, so over here, we've got an offer. Over here now, we're going to have an answer. They're going to be the same object, different type, and then they're going to have their own respective SDP to let the other side know what is being sent. Okay, once we've got that, this side now has everything it needs to set the local description, which will be the answer. This side creates the answer. I'll put -local, and down at the bottom I'll put offer, and the offer will be the remote. And it is ready to go in terms of I know what they're going to send. The ICE candidates were sent over to me, so I know how to get to them, so I am ready to go. Okay, it needs to send its own answer up to the up to the signaling server. So we'll come from this side over here, send up the ICE candidates, and send up the answer. Right? The signaling server takes that and says, "Hey, client 1, I got good news for you. Somebody sent me an answer, and somebody sent me some ICE candidates. Okay, so over here now we have the offer is the local on this side, and the answer is the remote on this side. As soon as that stuff has been passed on through, we have answered both of these questions from both sides. Both sides have a local and a remote, which means both sides know which type they are, which type the other side is. They know what their codec is, and they know what the other side's codec is. With the ICE candidates, they know how to find each other. The signaling server is now done, and this connection can finish. Okay? I'll go over it one more time. Watch this video again if you need to. I know this looks crazy, right? If you just watched it for the first time, if all these concepts are new, I get that it's overwhelming. It took me a long time to figure it out. But the process is really comes down to this. The browsers cannot find each other on their own. They need the signaling server, the Socket.io server, to help out because that has a domain. They do not know what the other is going to send. Somebody has to communicate that to them. That's the signaling server's job. Okay? Client 1, Client 2, they both go through the same process. Get some media, create a peer connection, give that peer connection some stun servers so that we can create ICE candidates so I can tell the other person how to get to me. Add tracks to the peer connection so we are actually going to send something when we finally get there. Create an offer if you're over here, create an answer if you're over here. That thing is your RTC session description and is going to answer this question. Take both of those things, take this, the offer, or this, which is the answer on this side. Take the ICE candidates, which you got back from the stun server, send them up, like we already talked about that, send it up. Once both sides are connected, send it across. Make sure to set the remote because you got the other sides now. I got the other sides, and you'll be connected. Okay? It is going to seem like magic the first time. I totally get it. As you work on it, it will make more sense. Let's go look through our code. I am over to github.com, and this link will be in the description so you can follow it or you can type it in, github.com/RobertBunch, which is my username, and then the repo name, which is /WebRTC-starter. I don't use any third-party stuff at all. I've kept this as absolutely simple as possible. I can't stand it when I'm trying to learn something new and there's a bunch of third-party stuff in there and I have to make accounts. And I want to know that I can reproduce this. So I've kept this as simple as possible. So hopefully it will be useful to you beyond this video. But I want to help you get the code, and then we'll talk through briefly what assumptions I have made. If you know how to clone repos and that's what you want to do, go ahead and do that. Otherwise, click on the green code button and click download zip. And that will download the code to wherever your downloads go. You'll need to extract the folder out of the zip file and put it wherever you're going to work on it. So while you are getting here, I've got it open. I left it inside of my my downloads folder. You can see the path there. That's where I'm going to work on it. Put it wherever you need to. The things you need to know. I am on my Windows machine. It shouldn't matter, I hope, because I, for the terminal window, am going to use PowerShell. If you are on a Windows machine and you're not using PowerShell, I would love to know what the reason is because I can't stand the DOS terminal anymore. You are on your own. Linux and Mac users, I think all the commands will be identical. If there anything comes to mind, I will make note of it, but it should be exactly the same. You have to know JavaScript. I should have mentioned that already, but it is a JavaScript API. It won't make any sense here if you don't know JavaScript. You have to have Node.js installed. And for all of this stuff, if you need help with it, I may have a playlist either in the description or on the way, one of the two. But you have to have Node installed. I can link a video on how to do that. You should have it already. If you're looking for help on how to use Node, the same holds true there. We are going to, we just have two dependencies, and they are right here, Express and Socket.io. Yes, make cert is there. We'll talk about that in a second. We're actually going to install that independently. But Express, we need that in order to serve up our files. That's why you have to have Node installed. We also are going to use it for our Socket.io server. This is the thing you're most likely to be unfamiliar with. It happens to be something I'm passionate about, so I'll have a playlist that covers it. It is pretty straightforward, and there's a good chance you'll be able to follow me. Again, it's not strictly speaking WebRTC. It is the signaling server. I don't think I've ever done a WebRTC app without Socket.io or WebSockets. So you'll either need to be familiar with that, or you'll need to just trust me and be able to follow along. Let's go ahead and when you are up and running, go to your terminal window, and in the folder that has the code in it, in my case it's WebRTC starter main, run npm install to install Socket.io and Express. Okay, and I'm going to use NodeMon. You can use NodeMon is, I strongly suggest it. If you don't use it, it will restart the server if you make changes. But if we run it on server.js, we will get an error, and it says cert.key is missing. So I'm going to kill the server here and hop back over to server.js. And you can see here on line 3, I'm running HTTPS, not just HTTP. Scroll down a little bit further here. I am running on port 8181. So we'll get to that in a second. But I am assuming we're going to run this on HTTPS. If we come back over to the docs quick to GetUserMedia, so you can just search for GetUserMedia. This is the URL. But it says right here, this has to be run in a secure context. This feature will only work in HTTPS. Some browsers will support localhost, some won't. So I'm just going to assume we're running it on HTTPS, and then we will all be on the same page. So in order to do that, if you come over to the GitHub repo inside of tasklist.md, which we looked at briefly earlier, up at the top here, I have the process for installing or setting up HTTPS on our local here. I'm going to copy this command, make cert-g, come back over to the terminal, and I am going to paste that in. The -g means it will install globally, so you can use make cert anywhere on your computer. We come back over, let's grab this number 2, create CA. This will create the certificate authority, not the actual certificate yet. So you can see it creates these two files here, ca.key and ca.cert. If I open this up, they are right here. So you want to see those inside the root of your folder. And it'll be some ridiculous hash, okay? It will not be readable at all. And then lastly, we can actually create the certificate now that we have the certificate authority. So grab number 3, paste that in, and then it will create those two files that we saw a minute ago. Okay, so if I run NodeMon on server.js again, you should hopefully have no errors, which is what we want to see. So if you come over to localhost 8181 without an S, you will get this page isn't working because we're not serving it up on regular HTTP. If you put in HTTPS, you will get this screen, okay? And if you want me to go into more detail about how make cert works, I have a video that I'll link in the description as well. But it is going to, whatever your browser is, it should say, hey, this is trouble. I don't know that this is safe, okay? If you click on not secure up here, it'll say the certificate's not valid. That's because we made it and it isn't signed by a trusted authority. In my case, Chrome has no idea who signed this. It was my local. So you're gonna have to proceed and trust yourself, or you won't be able to actually see the application. But that brings us to the page which loads up. And if I'm gonna grab the console here quick. Okay, I'm gonna click on call. This is how the application is gonna start, but it is gonna, but I got a little ding there. It says the device is in use. I'm gonna have to disable my video stream in order to show this. I will be right back. I have refreshed my page, and if I click on call, I have already allowed it, but it probably will ask you if you want to give permission. You can see that up here, this little icon says, hey, these are the cameras that you have allowed, just sort of for future reference. You can see my my green screen that needs ironed badly, and a whole bunch of chatter down here. Okay, so we've got the feed coming through. If you copy this link, I have opened up an incognito window and pasted it in. Back over here, I've generated an arbitrary number for the user so we can keep them separate. This is 71391. I'll refresh this. There we go. We get something different there. 28885. If I click answer here, because this is incognito, it'll want to make sure that I'm okay with that. And we have the feed on both sides. Except this is not all that helpful because it's the same feed. How do we know that it's working? Well, I'm going to refresh this and get rid of that. We're going to come back over to server.js here. And line 24, I'm going to take you quickly through this so that if you would like to run it on another device, I'm going to run it on my phone. More than likely, you have a phone with a camera in it. You can go through this process. I'm going to uncomment that inside of our core's origin here. And we need to put our local IP address. So whatever network you are on, you should not expose your public IP address. That is not safe. But if we come back over to the terminal, kill the server, and on Windows, you run ipconfig. On a Linux machine, it'll be ifconfig, but you need to find your local IP address, which probably starts with 192.168. It depends on how your network is set up, what your CEDAR blocks are, and so on. But this is my local IP. Yours will probably be different, so you'll need to do a little bit of that legwork on your own. But if I paste that in here, I can now come to this URL instead of localhost, go to this :8181, and my phone as well as my desktop will be able to hit it, okay? We need to go over to scripts.js, and we need to change that here, line 6. So I'm going to comment out line 7, comment in line 6, and I've got that same thing, local dev IP here. I'm going to paste that like so. Again, don't do this public. That's not safe. Do your internal IP address, and that is okay. Okay, so run the server again. So nodemon on server.js. We'll come back over here and refresh. Okay, that initial call is gone. It doesn't work anymore because we're not running at localhost. We're now running at 192. So you'll need to change this to whatever your local IP address is. Again, mine is 192.168.144. It's going to give us that same, oh no, are you sure this is okay? We're at a different domain, so Chrome is doing its job in my case. Click Advanced, Proceed, and I am back to where I was. I am going to load this up on my phone, so I'm going to click Call. My feed will show up here. Let me punch this in. Okay, I get that same, I'm afraid that this is dangerous. I'm going to proceed, tap the green button, and there we go. You can see, let me get rid of this. Okay, here I am on my phone, and there I am on my webcam. This is weird, so I'm going to get rid of that. You should be in business at this point where you've got your own feed locally here, and then if you want to run it somewhere else over here, you can. If you want to use localhost, that's fine. Again, I prefer when I'm doing WebRTC to be able to test it out this way. So you should be up and running on your local so that now you can tinker with it if you want to. If you want to check console.logs and so on to see what your stuff looks like. What we did is back in tasklist.md, we installed makecert globally. We created a certificate with these two lines here. And then I have line 4 optionally to run it locally, update the files with your local IP address. That's in those two places here in our core's origin on the server, and then in scripts when we connect to the socket.io server. Okay. We also ran npm install to get Express and socket.io going. Okay. So let's talk through our code. Index.html. There's no reason to look through any of that stuff. Index.html is our first file, and this is being loaded up by our Express server. So we'll come back to that in a minute, but we have just a bunch of HTML tags. I am using Bootstrap, so things look a little better than they otherwise might. We've got some Bootstrap stuff here. This is where the username goes. I put that in there just so that you can keep it straight. If you're on the same computer running two different tabs, you'll be able to tell which is which. This button here is that call button. So hopping back over here, that's that blue call button. There's a hang up button as well right next to it. And then the answer div, this gets populated as more offers exist on the server. So this will add a new green button for every offer that exists. This videos div here, our video tag is right there, and that is for the local video. This video tag is for the remote video. Okay, we've got waiting here. If you initiate the call, as you already saw, it will put waiting on there. That's why I've got a little bit more here. It's the same thing essentially, just with a different ID. I have autoplay, plays inline, and controls. You can fiddle with those if you want. But this is where we're going to put the local feed once we run GetUserMedia. Once we get video from the other user, we're going to put it in here in line 24. Okay, so this is all of the videos. This is just the local, and we have this waiting which will show up until someone actually answers on the other side. Okay, that is it for the HTML. Down below we have socket.io. This is going to get added or created by the server. We don't need to create that file. That's built into socket.io or how it works. Our scripts.js file we will look at in just a second. Line 30, I have separated things out so that scripts.js is going to be pretty much the WebRTC stuff. And then the socket listeners right here is going to be the listeners that we add to socket.io on the front end. Okay, so that's why we've got both of these files. It just keeps things separate, makes things a little bit easier to find. Okay, so please let's go to scripts.js. Like I said, I have a username and a password here. The password is garbage. I just included it for part of the template. I will show you where socket.io looks for it. As I said, we generate a random number here between 1 and looks like 100,000, and then I just stuck my name to the front of it. You can do whatever you want with that if you want to change it. We take that once it's generated and put it inside of that div we looked at a minute ago. Okay, line 6. This is when we are connecting to our socket server. So IO, where does that come from? Well, back over in scripts.js, back over in index.html, I mean. This thing right here, line 28, that is going to add the IO object to the window. So scripts.js, we have IO because we have socket.io included right here. And if we come back over here, I can prove it to you. If we open up the console and console.log IO, it's right there. We can do the exact same thing with window.io, the same object either way. Okay, so that's where that comes from. We are connecting to our Signal server. So the Signal server has to be up, our node server, which is socket.io. This has to be running in order for the app to not break, otherwise JavaScript will complain. And we send an object, so this first thing is the URL where the socket server is at. The second thing is an object, and it has auth, and we send up username and password. Okay, let's hop over to the server just real quick before we go any farther, just so that this is clear. Inside of server, we bring in the FS module. That's part of Node.js. You don't have to do anything. You don't have to install that. That's just a native core module. HTTPS is the same way. Express, we npm installed that. Remember, that was in our package.json. We create an app. This is going to make us an Express app. We bring in socket.io. This was in our package.json. So these are the two things that we actually had to install. And then line 7 here, app.use, what that does is it tells Express that if you find any file in the current folder, serve it up. That's why when we come over here, our index.html file loads up just fine, because this line is here. It tells Express, serve up all the HTML, the CSS, and so on. Okay? This part here we already looked at briefly, but this is why we need the FS module, the file system module. We need to get the contents of these two files so that on line 18, we have our Express server, which we run HTTPS, we call createServer, we hand it an object with those two files, and then we hand it the Express app we created back here on line 7. Okay, so this thing right here creates a secure HTTPS server that is going to handle static files as well as HTTP traffic. Okay, so watch that again. If you need to, you can ask questions, of course, too. Line 20 is where we actually create our socket.io server. So I call it IO, and then we run socket.io. That's the node module we imported back up here on line 6. And we handed our Express server, that's the HTTPS server we just made. We give it a second thing here, which is an object. It has cores. We have to put this in, otherwise the browser won't be able to get here. And then you give it a property of origin in this object with an array of all of the valid domains. So right now, you can come from localhost, or you can come from this local IP address. Otherwise, you will get blocked. And then lastly, what methods are okay? Get and post methods are what the socket.io server will actually listen for. And we saw this already, but this is running on port 8181. So back over to scripts. we send up the username and the password. Well, on server, if we scroll down a little bit, the very first thing we do, and this is Socket.io, and I'm going to get away from here and back to scripts. I just want you to know where this is. io.on, so io is our Socket.io server right here. We are going to listen for this event, the connection event. You can think about this like an http.get, okay? You give it a route, except here, this is TCP traffic instead of HTTP traffic. If someone connects, we're going to run this callback. Just like in Express, you'd have rec and res in here. We just happen to have the socket. Right here is where you can pull out the username and the password, which are coming up in that auth object. Okay, so back over in scripts, we are sending up this auth object. It has a username and a password. The username and the password are right here on line 1 and 2. We send those up. Back over to server, we have username and password as part of that auth object. You can make decisions here if you want to disconnect them as, hey, you gave me a bogus password, then it will disconnect the socket. If you wanted to put the username in somewhere, we actually do use that. We'll talk about that later. But that is, we'll get away from Socket.io, but that's what the username and password are for. They are not essential, but they are nice to have. That gets us to where we have our username on the screen. We have connected to our Socket.io server. We've sent up the username and password. Let's do the WebRTC part now. Just a convenience variable, we grab the local video div and the remote video div because we're going to need these in a couple different places. Create a couple different variables. Local stream, this is a variable that's going to hold the local stream. We're going to drop that in this element. Same thing for the remote stream, we'll put it in this element. The peer connection, this is empty right now, but that's where we're going to create our local peer connection so that the two clients can talk to each other. Line 19, I have a Boolean called did I offer. This is just, again, a convenience variable that we can send up to the signaling server. It'll make it easier to sort and figure out who the offerer is and who the answerer is. Remember, there's two sides to every connection. That will do the trick there. Okay, line 21 down to 30. Remember, we talked about the stun servers. That's what we've got here. The property, though, is ICE servers. So we have peer configuration. When you create the peer connection, which you'll see here in just a second, it is in this function. We're going to pass it this thing, the peer configuration. It is an object, and the object has one property for us, which is ICE servers. And we're going to send it an array of one object. That object has a URL property, which is an array, which finally we get down to our data. It's multi-layered for configuration options. Don't worry about any of that. That's not important in this introduction. The important thing here is that this is where you put your stun servers. The stun servers, if you remember, will figure out how to get to us so we can tell the other client. And these are Google's public stun servers. You can use different ones if you want. It's stun.l, and then this one is stun1.l. Okay, so we will use this. I'll reference it in a little bit, but these are our stun servers. That's why they are there. Okay, we get to this part. Const call. This is a function, so we'll skip over top of it. We have another function called answer offer. We're going to skip over top of that. We have add answer. Skip that. Fetch user media. Skip that. Create peer connection, and then finally down at the bottom here, we get add new ICE candidate. We get down to line 156. So these are all functions, and we will talk about them when we call them. Line 156 is the next line that will actually run. We grab the call button. So that is in index.html. That is this guy right here. We grab that, and we add an event listener. We add the click listener so that when it's clicked on, we will run the call function. So come back up top here. Someone has clicked on that lovely blue button, and we will run our call function. We call await here, so we have to have async, await for this function to run. Remember, I said I'm going to block the program until the user approves. Well, let's go down and check out fetchUserMedia. It is right here. So my line 81. fetchUserMedia returns a promise. So that's why we have that await there, or we can have that await. We return a new promise, and we have a try catch block here because we're inside of an async. Line 84, this is that miraculous line where literally in one line, I have commented out audio there, but you could do it in one line. You could get the user's feed. It's mind-blowing. But we store in a variable called stream, call await, because this thing's going to return a promise. Navigator is a native window object. Geolocation, if you've seen, you search for pizza on Google and it'll say Google wants to know your location. The Navigator object is where that's at. Well, Media Devices is also inside of Navigator. Media Devices has the getUserMedia GUM method, and you don't have to hand it anything, and it will automatically assume audio and video. I've got the object here. I have included video true, and I have commented audio out, because if you're running the same app on the same computer, you will get some nasty feedback. So you can uncomment that if you want to. The reason I have it commented out is just to save you in case you're in a situation where that would be bad. This right here is what prompts the browser to say, hey, this website wants your feed for your camera or your mic or your screen. Is that okay? If they answer yes, then the try will succeed. We will grab the local video element, scrolling all the way back up to the top here. That is this thing, the thing with the ID of local video. So we talked about that already, but that is this tag right here. It's going to grab that video tag, and going back down to the bottom here we are. It is going to drop the stream over the SRC object of that element. So this will play the stream, and that's why it shows up immediately. We take our local stream variable, that was one of the lets we had back up at the top, we just initialized it, set that equal to the stream so that we can send it to somebody else later on, and then we resolve the promise so the await can move forward all the way back up here. When we await, resolve will make it so that we can go on to line 35. If, back down here, if they don't allow, so they deny us access, then reject will run and the promise will fail, okay? Or the promise will go through the catch. So as of line 34, we now have our local video stream stored inside of this variable, and we have loaded the feed inside of this element. What happens now? Well, now we create our peer connection. So line 37, we do the same thing, await. So we're gonna block the program until this function finishes. So let's hop down to that. It is on my line 98, and you'll see there is an offer object here. That's not gonna come through this first time. As you just saw, whoever initiates the call will not send this, which means it won't exist. So sit tight, we'll get to that in a second. Remember, we called await, so we have to return a promise. And I've got some comments here. RTC peer connection is the thing that creates the connection. That was that dot that is very, very, very important. We can pass a config object, and that config object can contain stun servers, which will fetch our ICE candidates. Line 103, we are going to create a new RTC peer connection. This is built into JavaScript. So if we come over here, I hop over in the docs, RTC peer connection is an interface, which is a fancy word for like a glorified object. It represents a WebRTC connection between the local computer and the remote peer. So come here if you want to see what the different methods are. We're going to use a bunch of these. Add ICE candidate, add track, add stream, create answer, create offer. All of that stuff is going to be here in the instance methods. Okay, so we're making a new one of those. It's built into JavaScript. This is part of WebRTC, and we're going to pass it peer configuration. Peer configuration, back up top here, that was this guy where we have our stun servers. So we are passing this thing into our RTC peer connection. We set the remote stream to just create a new media stream. That's a JavaScript thing. That's strictly speaking not WebRTC. WebRTC just uses them. And then we overwrite the SRC object of our other video tag to that remote stream. There's nothing in here. That's why you get that little turning arrow. Until a stream comes through, that won't actually be populated. Okay? Line 108. If you're following along in the user tasks, or the task list here, we have done number 1. We called getUserMedia. We just created the peer connection. Line 3, we've added our stun servers to it. Line 4, we need to add our local stream tracks to our peer connection. So back over to scripts, we grab our local stream, we call getTracks. GetTracks is a JavaScript method. This is built into every media stream that exists. We're going to grab all the tracks. You will potentially have two. You will have an audio and a video if you included both, or you'll only have one if you only included one. We're going to loop through those. Okay, again, you'll have one or two. Call the one we're on track, and we're going to call that add track method, which I showed you back over here. It is right here. We're going to call add track, and we are going to add some new media tracks to our peer connection. We give it the track, and then we give it the stream that we want to add it to. So back over to our task list, that's line number 4 here. We got these from our getUserMedia. We are going to add tracks to our peer connection. Which tracks? All of the tracks that we pulled from getUserMedia. Okay? We're going to add a couple event listeners here. This one on line 113 is purely for your reference. We're not gonna see this for a while, but the signaling state change is useful if you're trying to troubleshoot signaling errors. I'm just logging the event, and then whatever the new state is, don't worry about that for now. Line 118 is going to run whenever we get a new ICE candidate. So this is built into WebRTC. If you come back over here, you'll see that stuff down here. Scroll down to events. Right here is the ICE candidate. You can look at this if you would like to, but every time a new one comes in, and why would one come in? Well, because when we created our RTC peer connection, we gave it some stun servers. So right here, this will trigger, this callback will run whenever a new one comes in. I log that we found one, I log the event. If there's an actual candidate, sometimes there's not, just in case, then we will send this up to the socket server. We will come back to that again when it's socket IO time. So lastly, we're going to add another event listener. This is the track listener. Coming back over here, this is another event that belongs to the RTC peer connection. We can listen for new tracks. That means a new track has come from the other side, or rather to the connection. Okay, we're going to listen for that. If it comes through, we are going to add that track to the remote stream, which is going to be exciting because if we scroll back up, we set the remote stream here to that video tag. So if we get a new track that comes from the other side, and we're not even close to that yet, but when it happens, we will loop through those tracks, we will add them to our remote stream. Who cares about that? Well, our remote stream is playing inside of our video tag. That covers us for that one. Lastly, if there's an offer object, there isn't, so we'll come back to this later on. We resolve our promise. Okay? That is the create peer connection thing. We build our peer connection, we hand it our stun servers, we create a new media stream for the other side for when the time comes. We grab our local tracks and we add them to that peer connection, and then we add some listeners. These are all going to be useful as things happen. They just haven't happened yet. The signaling state changes, we get a new ICE candidate, we get a new track, etc. Okay? So let's come back up to the top here. We've done two things. Lots of code we've already looked at. Let's do a real quick review. We run call when the user clicks on the call button. That calls fetchUserMedia. It does all that stuff. Once it has resolved, then we run createPeerConnection. It does everything we just looked at, sets the peer connection up, passes the stun servers, adds some listeners. Once that is finished, we are going to try and create an offer. Okay, remember this person clicked on the call button, so we are going to assume they are the offerer, not the answerer. So line 42, we are going to await peerConnection.createOffer. This is built into WebRTC. So back over here, go back up a little bit, createOffer. It's right here. If I click on that, you can read about it if you would like to, but it creates that SDP. We talked about that. It has the WebRTC session codec, whatever options, etc. And then any candidates already grabbed by the ICE agent. That is an async operation, so we're going to wait for it. I log it here so that you can see it. So I suggest go ahead and click on call and see what that thing looks like. I'll go do that in just a second. Once we have it, we set the local description. Remember, we have to tell ourselves, our peer connection, this is my SDP and this is my type. A little bit later on, we're going to run set remote description and hand it the answer from the other side. And if you want to see set local description, that is over here as well. Down here, set local description and set remote description both. So my line 43 is the offer, just so that you can see it. I have fired this back up, going to scroll up here. This is that RTC session description. We talked about that, but it has two properties, an SDP and a type. The type is the offer. A little bit later on, it'll be the answer, and then the SDP, this is, if you want to click on that, you can copy it, come over here and paste it in, and you can see, need to turn word wrap on. Okay, this is all the stuff that it knows about my video feed that's coming through, all of the timings and the codec and so on. I don't want to look at that anymore, so I'm going to close it. On to line 45, did I offer? That is true because this is inside of the call function. And then we call socket.emit newOffer and we pass it the offer. That is the end of the call function. That means at this point we are finished. Now you can see a bunch of the events have happened. Line 114, even though there's no answer, line 114, 15, 19, 20 happened. If we come over and scroll down there, line 115, a signaling state changed. So you can follow, hey, something happened on the signaling server. Line 118, the ICE candidate, something came in, that's 119 and 120. Let's take a look at those quick. 119, here's my ICE candidate, open up 120. Our candidate, if I open that up, it shows the address and then it shows the candidate using UDP. This is all the information, the ICE candidate itself, that will get sent to the other side so that they'll be able to find me. Now this isn't the only one that it generated. If we keep going down here, grab another one, open this one up. This one has a different IP address in there in case the other side needs to use that. But back up to the top here, inside of call, we have finished call. We have emitted our offer. That's going to go up to the server and it's going to sit there. Let's hop over to the server quick. Inside of our socket server, again, we are going to, on connection, we're going to run this code. We're going to call this particular connecting socket for the life of this callback, which is pretty much the entire file. So socket is going to be whoever just connected. And if we look back in scripts, we have the newOffer event. We go to newOffer, we call the thing we got newOffer, and we add it to offers. What is offers? Well, scrolling back up top here, this is an empty array. And this offers is going to contain a bunch of objects, and I have the format that our objects are going to follow. These are all of the properties that are going to be on there. Now, coming up initially, the only thing we're going to have right now is our newOffer. We're going to slowly add the other stuff here. So the offer property is the offer we just got. The offer username, that's the username which came through back up here when we connected. Remember, we sent that up. The ICE candidates for the offer is an empty array. We will add them as they come in. The answer username, we don't know who that is yet. The answer, we don't have it yet. And the answer ICE candidate is an array. We will add those as they come in. So this has added the offer. The server now knows someone has sent an offer up. If you scroll down here, line 74, anyone who is connected already will now get the newOffer awaiting event. We're going to send out the offer that just came through. So we're going to grab the last element and send it out as what that line does. The reason I've got socket.broadcast here, if you know socket.io, is because we don't want to send this out to the caller. They should not be answering their own call. So the socket server has added this offer. It's waiting for someone to answer. So we got newOffer waiting. If we come back over to scripts, that's not going to be in here. That's going to be inside of socket listeners. Real quick, let's look at our task list again. We've got our client 1 has created the offer. It has these properties in it. We gave it to the peer connection. ICE candidates started coming in. We saw that in the console. The signal server has been running. It's been waiting. We emitted the offer up to the signal server. The socket server is holding it for the other browser, really for any other browser. It's associated with client 1. How so? Well, when we made our object here, we've got the offer in there along with the offer username. And then lastly, as number 7 happens, we can start sending up the ICE candidates. Well, we'll look at that again in a little bit. Client 1 and the signaling server are now waiting for client 2. Again, we sent out the new offer awaiting. Inside of socket listeners, okay, this is our other front-end file. Inside of socket listeners, we have a new offer awaiting. If that thing happens, then we run createOffer elements. Likewise, we have available offers too that runs the exact same code, okay? There are 2 occasions when an offer needs to be sent out. It would be if you join for the first time, or it would be if you're already here and the offer was just sent out. So we go back over to the server, you'll see as soon as someone connects right here, we send them all the offers that we know about. That means that you just joined. If I have any offers, I will send that array to you. Okay, an array of these objects. If an offer comes in and you're already connected, then I am going to broadcast this. So those are the 2 occasions. It'll be one, someone just showed up, let me give you what I've got. This one will be, hey, I just got one and you're already here, here you go. We've got this is going to run in both cases, that's down below here. We're going to create a new element. This is just going to do some HTML. We're going to build out a div. We're going to put the green answer button in there, put whoever the offerer's name is, and then we're going to give them a new button to click on that's going to run answer offer, and then we're going to pass the offer to it. So this function will run anytime we get a new offer. We're going to create some HTML, put it in the DOM, and then we're going to add a click listener. Just a quick note here, I've got inner HTML. We're using their username. This would not be safe to run in production. You should figure out another way to get the username on the page. Just a quick note there, okay? We're going to run answer offer when someone clicks on this new green button. So over to scripts, if we go to answer offer, I'm happy to say there's a lot of code here, but it's basically the same thing. We call fetchMedia. We did exactly the same thing up here inside of call. We call createPeerConnection. We did exactly the same thing up here in call. So we're doing the same stuff here. This time though, we do pass the offer object. Why? Well, if we go down to createPeerConnection, if there is an offer object down at the bottom here, if the offer object exists, then we can set the remote description. Remember, the offerer, client 1, sets the local description to the offer once it's created. Here, we're going to set the offer to the remote because this is client 2. This is the person answering. That's the only reason that's there. This isn't going to be called from call. It's only called from answer offer. Okay? So client 2 will have the offer in as its remote description. We come back up to our answer. Where are we? Answer offer. We created our peer connection. Now we're going to create an answer. Just like up above, we called createOffer on our peer connection. Now we're going to call createAnswer. In line 57, we take our answer and we set the local description. Exactly the same thing we did before, but we did set local description. We passed it offer. This is client 2. This is the answerer. So we do just the opposite here. I've got a couple logs here so that you can look at them if you would like to see them. Line 62, we take our offer object. Okay, what's the offer object? That came from socket.io. That came from our socket server. So our offer object, back over to our server, it has all of this stuff in it. Right? It had the offer in it. It had the offer username. It's got any offer ICE candidates. Back over here to scripts, we're going to set the answer, the object, we're going to add answer to it, and then we are going to take our offer object and we are going to send it back up to our server right here. So we're going to emit back up to the socket server our offer object, which now has the answer. Okay, so we've added this locally. It's a local edition. You can't add a variable from here on the server. We've added it locally. We're going to send that back up to the server. with this event. Emit with acknowledgement. This means we're going to expect Socket.io to send us something back. It's going to send us back the ICE candidates. Okay, so we'll come back to this in just a second. But our new answer is going to be the same as the old one, but it's going to have this on it. So back over to server, scroll down a little bit farther. Here's our new answer event. This just happened, right? On new answer, we're going to run this code all the way down there. We get our offer object. The acknowledgement function, that's what's going to send back this variable, our offer ICE candidate. So we're going to run this when we're done. Sit tight for a second on that. But line 82, this is going to be the socket that we are answering. So we are going to go looking through our connected sockets and find that, that particular socket. Come back all the way up to the top here. I have a variable on line 40, which is an array. And we put, whenever someone joins, we add an object which has their username and their socket ID. The reason for this is it makes it a lot easier to find that particular socket. This is a socket ID thing, but the point is we need to find who they are in this array, and that is added right here on line 53. When someone joins, so this is as soon as a socket joins our socket server, we push them onto this array. It's their socket ID and their username. So down below here, we're going to go find the socket we want to talk to. Okay? If it doesn't exist, then that person has left. So they created a call. There's a call, or there's an answer rather over here, but they have since left, and so we won't be able to find them. If we did find them, we will hold that and we're going to emit later, but we need to find the offer and we will use their username to do that. So we're looking for that username. This is, again, just a way to find out who sent us this offer. It's primitive. There's lots of ways you could do this, but we need to find the offer in our offers array, so match that up. Find the username, match it up. If it doesn't exist, again, we don't have that person anymore. Otherwise, let's run our acknowledgement function and send back that person's ICE candidates. The answer is still who we're working on here. We have a new answer. They have their own answer and they have the other side's offer. This is going to send back the ICE candidates, so they will be all set. They will know how to get to the other person and they will know what they are speaking. In our offer to update, we're going to add the answer. This is for client one, the offerer. We're going to add our own username, and then we are going to send out this event back to the socket who made this offer. So we're going to send out this event, which has the offer to update, okay? The offer to update, it's this thing, it's this object. It has this already, this already. They know their own ICE candidates, so it's already got some of those. It now has this and this because we added it right here. We added the answer and the answerer username. That's answer response, so we're going to update with that new object. Back over to socket listeners. We come back up and we look for the answer response. We have a complete object now. It has the offer, the answer, the other side's username, our username, and so on. So we call add answer, and we are home. If we go back to scripts, the add answer event, all it does is take the peer connection and it sets the remote description to the answer, which is the SDP and the type, right? This is the RTC session description that the other side created. That is the whole process. As soon as this happens, the set remote description, that is going to add tracks because we got a track from the other side. It is going to start adding those tracks to the stream and it's going to start playing, and that's what makes the magic happen. The very last thing to talk about, as ICE candidates come in, whenever we get a new one, and that's going to happen asynchronously, right? We sent the stun servers up to the peer connection. This event is going to run send ICE candidates to the signaling server. If we go back over to the server and we look for that, it's right here on my line 104, we got a new ICE candidate object. This is where that did I offer boolean is going to be useful. It's going to come through with the ICE candidate. We are going to check to see, are we the offerer? If we're the offerer, go find the offer. The offer was added back up here to our object right here, or our array on line 32. That's the thing that we've been passing around back and forth. Well, we're going to find that offer. We are going to push onto the offer ICE candidates, the one that we just got. Down below here, if we're not the offer, then that means we're going to do the same thing, but we are going to add this to the answerer ICE candidates. So we're going to go find the same offer, find the right socket, and send those ICE candidates out to the other side. Okay, so received an ICE candidate from the server. This event right here, emit the received ICE candidate, that's going to go to whoever the other side is. If they are connected, we will send out to them the ICE candidate we just received. Okay, so last time, back over to socket listeners, if received ICE candidate from server comes in, it will come to the correct socket, right, from the answerer to the offer, or from the offer to the answerer. We're going to call add new ICE candidate. That's back over in scripts here. Add new ICE candidates down at the bottom. We run peerConnection.add ICE candidate. Okay, that's the whole process. I know there's a ton here. I know there's a lot of code. Watch it again, or follow the parts again that you need to rewatch. It really comes down, though, again, to our task list. It looks intimidating, but just like we drew on the board, both sides have to get media. Both sides have to create a peer connection. Both sides have to send stun servers so that we can find them. Both sides have to add their locals tracks to their peer connection. And then client 1 creates an offer. That's the SDP and the type. They add that to their local. The other side is going to create an answer and add that to their local. As soon as that happens, we start collecting ICE candidates, and we send both the offer and the ICE candidates up to the socket server. Down here, we pass the answer and the ICE candidates up to the socket server as well. Once the socket server knows the other side is there, that's all the socket server is doing here. And again, I know this is probably the most confusing part. For one thing, TCP is hard to follow because it's asynchronous and you may not be familiar. But all this thing is doing is keeping track of all of the offers that have come in, and then whoever the new person is, if they are the offerer, I will keep track of this stuff. And if they are the answerer, I'll go find this thing and I will add the appropriate stuff. The socket.io server, server.js, its main job is to send out offers, answers, and ICE candidates. As soon as that part is done, I guess it's this event down here, as soon as that part is done, then the socket server is no longer necessary and the peer connections can talk. Okay? Fantastic job. If you made it to the end of the video, please feel free to ask questions if you've got them. I would love to help you out any way I can. This is exciting stuff. Check out other WebRTC videos I've got and look for that playlist.